3. I can solve real-world problems using systems of linear equations. All right, so your Frere model should have system of linear equations. So write that in the middle of your Frere model, please. And the title for your notes, I want you to title it Applying Systems. Applying Systems. So we're done learning the different methods to solve systems. What are the different methods? Graphing, substitution, and elimination. Now we're going to apply them. We're going to apply them. Okay? So here we go. Systems of linear equations. Fill up your Frere model by yourself without looking at your notes. See how well you remember. We did last week, we actually started the Frere model. We know the definition, example, non-example, and come up with 2 hashtags. I'll give you guys a couple minutes. Go. Okay, let's see. Definition. The set of 2 or more linear equations that have the same variable. Hands if you got that. Okay, good. By now, like a lot of you know it by now, you need to know this hint. Example, non-examples, and hashtags. Something like that. Hands if you got something similar. Okay, good. All right. And once again, in regards to steps, you already know the steps to solve using systems of equations and different methods, right? However, today is going to involve application of it. So set that aside. We already have the notes for the Frere model. So today we're going to focus on problem solving. So throughout the year, I've already given you a problem solving strategy. Is that correct? That we've been using. Share with a neighbor the problem solving strategy that we've been using when we approach word problems in algebra. Very good. Q. That is correct. We start with the first one, which is circle important numbers. From there, we go underline the question. From there, we box important terms or ideas. Step 4, exclude unnecessary information. And at the end, we draw pictures, diagrams, tables, labels, etc. So once again, you already have this, and we've been using this. In case you forgot or in case you are missing, remember, it's in the poster that's been here all year, over here next to the iPad cart. When you go get your iPad, I'm pretty sure you stop by and read it, right? Okay, good. Write this down, example 1, underneath your Frere model. Write this down. It says, example 1, Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? Copy that, please. I'll give you 1 minute. Go. All right, so it says, once again, example 1. Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? Now, earlier I sent this around. Did everybody feel it? And by the way, this is going to be our pass. Bam, bling, bling. And now that you felt this, right? Everybody felt this? This is what we call felt. This material is called felt. It's kind of spongy and it's kind of like cardboard, but it's not. So anyways, so that's what they're talking about here in this problem. So let's start cubing this. Cubed. So with blue, I'm going to circle important numbers. So she has $7.75, 12 sheets. Felt costs 50 cents. Cardstock costs 75 cents. Okay. Let's underline the question or questions. How many sheets of each can Sonia buy? All right? Let's box key information. Key information here is that it's talking about felt. I'm going to box felt. And I'm going to box card stock. Card stock. felt, and cardstock. Okay? Exclude any other information, and draw a table, diagram. So we're going to draw a table. Now, who notices now in systems that instead of coming up with one equation, we have to come up with two equations? Yes? So check this out. I'm going to show you a table that we're going to use from this point forward for systems of equations. Here we go. And it doesn't change the setup. So here we go. For the setup of a system of equation table, you draw 3 lines down, 1, 2, 3, and instead of only 1 across, we're going to draw 2 across, because now we have to come up with 2 equations. Okay? What do we usually write over here at the end of our table? Total. That's still there. Total. Okay? So let's see. What is the first item that they talk about? Felt. That goes here. Felt. What is the second type of item? Cardstock. Goes here. Cardstock. Okay? So now that we have that, let me ask you this. They're talking about items here, right? And if we were to change this problem to something else, let's say they talk about fruits or cats and dogs, it's still different items, yes? So this kind of problem is known as an item. And what else are they talking about in this problem? What is it? Money. That is correct. And that's what we call cost. So this problem is called an item and cost problem, which means we're going to label the first row item, and the second row we're going to label that cost. So let's start with the item. I'm going to use just right for this row for items. So let's see. Items. What items are they talking about? Felt. Do we know how many sheets of felt Sonia's going to buy? No. How many of felt? No. What can we label it? X. Do we know how many of cardstock? What can we label that? Y. Do we know how many total sheets she's going to buy? How many? 12. It goes right there. And just to keep it in mind, felt corresponds to the variable X, and cardstock corresponds to the Y. Now let's go with the cost. What is the cost for the felt sheet? 50 cents. But since we don't know how many she's going to buy, what do we write? 0.50x. That is correct. So what do we write for here for cardstock? 0.75y. And what is the total amount that she's going to spend? $7.75. Do you guys see the system now? Let's write it out. X plus y equals 12, and 0.50x plus 0.75y equals 7.75. Are we there so far? Okay, so let me ask you this. This one's already in standard form, both of these, right? Which means which method could we use to solve? What is it? Cover-up method is for graphing. Yes. Elimination, right? Can we eliminate one of the variables? But at this case, we can't because these need a number here. So let me ask you this. Which variable would you like to eliminate? The X or the Y? The Y, okay. Which means we need to multiply this equation times what in order to eliminate the Y? That is correct, negative 0.75. That is correct. So this becomes negative 0.75x, negative 0.75y equals to negative what is 12 times 0.75? Yes. 9. Thank you. All right. So now that we have that, check this out. Now we're going to focus our attention on these two equations in order to eliminate. Yes? So here we go. Which ones are we going to eliminate from there? The y. So these eliminate because it's a zero pair. So we got 0.50x minus 0.75x. We're left with negative 0.25x equals 7.75 minus 9. That's 1.25. And it's a negative. Can we solve? Yes. Divide by negative 0.25. Divide by negative 0.25. X equals, let's see, 1.25 divided by 0.25. Get rid of the decimals. 1, 2, 1, 2. No more decimals. So 25 fits in here how many times? 5. 125. And the x corresponds to what? Felt. So I want you to write there, felt. But now we need to figure out how many cardstock. Is that correct? So let me ask you this. From the first original two equations, which equation tells us the items that we need to find? The first one, which is x plus y equals 12. But instead of x, I'm going to write in there what? 5 plus y equals 12 minus 5 minus 5. Y equals 7, and the y corresponds to card stock. Let's write our statement. Sonia will buy 7 card stock sheets and 5 felt sheets with, how much did she have? $7.75. 10Q. Notice that the process in regards to solving the system we already know. But what's different now? The setup for the table and finishing up and answering the question in the sentence. Does that make sense? Okay? This problem in a parte will be worth 5 points, only this one problem. So if I give you 3 of these in a parte, that's 15 points. That's almost like 40% of the parte. Boom, that just happened. So, thank you. Let's do another one. Turn your paper over, copy example 2. Example 2, it says, Chris spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost $0.90 each. How many of each flower did Chris buy? Got 40 seconds, copy that, go. All right, let's see. Cubed. Let me circle important numbers. Important numbers is that Chris spent $14.85. 13 flowers. Lilies cost $1.25, and tulips cost 90 cents. Okay, that's important. Underline the question. How many of each flower did Chris buy? Okay. Box, key information. Key information here is that we're talking about what? Flowers. What kind of flowers? Lilies and tulips. All right? Exclude any other information, and let's draw our table. Let's see. How many lines down? 1, 2, 3. How many across? 2. Let's see. Help me with the top. What do I write at the top? Sebastian. What do I write here? Lilies. Tulips. Total. And help me out. What did you label this? And this one? Thank you. Pass it to someone. Alan, what do I label this next row? Roberto, help him out. What do I label here? Items. So what are we talking about? What items? Do we know how many? No, items. We're not talking about money. We're talking about items. Do we know how many lilies? So what do I label this? How about tulips? Why? How many total flowers is it getting? 13. Pass it to someone. Chris, what do I label this? Cost and 1.25x, 0.90y, 1485. Hands if you got that, please. All right, good. So, let's write our equation. Thank you. All right, let's write our equations. X plus y equals 13, and 1.25x plus 0.90y equals 14.85. All right. So, pass someone, Chris. Brennan, which one would you like to eliminate, the x or the y? The y? So what are we going to multiply by? Negative 0.90. That is correct. So this becomes negative 0.90x, negative 0.90y equals to negative negative 13 times 0.90. What'd you get, Chris? 11.70. Thank you. So now we're going to focus on these two. And now we can eliminate the y's, yes? That was a wise move. Damn. See what I did there? Yeah, okay. 1.25x minus 0.90x, that's 0.35x, equals 1485 minus 11.70, that gives us what? 3.15. Bam, Sebastian. Divide by 0.35, divide by 0.35. X equals, let's see, 3.15 divided by 0.35. Move the decimal twice, we get rid of it. 35 fits in there how many times, Daniel? 9 times, that's 45. We got 4, 27, 31, yep. 9, and the X corresponds to what, everyone? Lilies. So now we need to find what? Tulips. Which equation do I use? Pass someone, please. Who? Donovan. Tell me what to write. And instead of X, we're going to write 9 plus Y equals 13 minus 9. Y equals 4, and that corresponds to tulips. So, Chris bought 4 tulips and 9 lilies with 1485. 10Q. Boom. Fairly simple? Yes, Mr. Q, we love these. Well, guess what? There's a funner one. Yay! Be nice. Oh yeah, we have plenty of time. Copy this next one, please. Example 3. It's time to write that down, please. It says, example 3. With a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane speed? What is the wind speed? Copy that. I'll give you guys a minute. Go. All right, here we go. Let's get it started. Cubed. So, let's circle important numbers. 900-mile trip, okay? 2.25 hours. 3 hours, okay? Underline the question. What is the plane speed? Oh, this one has 2 quits. What is the wind speed? Plane speed, wind speed. Next, box key information. Key information here is tailwind. That's key. Next one, against the wind, which is part of the return trip. Okay. Okay, I think that's about it. We're going to exclude everything else. Let's draw our table. Once again, how many lines down, everyone? 3, 1, 2, 3. And 2 across. The only difference here, let me, instead of doing anything else, stop labeling stuff, just draw your table. Look up. Does this one have items and cost? No, this is a different type of problem. This problem, since it involves time, distance, and speed, this is what we call a rate problem. A rate problem. So the setup, just for the top part, is going to be a little bit different, and once we start filling in the other information, it's a little bit different. So let's label this. Let's see if you remember this formula from science. Rate times time equals what? Rate times time equals distance. Okay, let's begin. This first row, what are they talking about first? With a tailwind. So that first trip is tailwind. So I'm going to write here, tailwind. What does that mean? It means that there's some wind. And let me ask you a question. Like the other day, that it was really windy. And if you left school and you started running and the wind was hitting you on your back, is that going to make you run faster? Yes, right? That's what tailwind means, that it's on your back, it's hitting you on your tail. So tailwind, that's going to increase your speed. So check this out. Here where it says rate, in the middle, you're going to write a little plus because it increases the rate. Whose rate? Who are we talking about here? The plane, and what else? And the wind. So I'm going to use P for plane and W for wind. How long did it take on that first trip? 2.25, 2.25. And how long was that trip? 900 miles. Okay, there it is. So let's go to the other information. On the return trip, instead of writing return trip, what am I going to write? Against the wind. So I want you to write against wind. So let me ask you this. If you were to run against the wind, is that going to increase your speed? So what do I write here? P minus W. What was the time for that trip? And the distance? Still 900 because it's a return trip. So let's write our equations. Check this out. I got P plus W times 2.25 equals to 900. I want you to leave a space underneath Well, you wrote that, and let's write the second equation. The second equation is P minus W times 3 equals 900. And now we can probably start solving, but it looks kind of funky, doesn't it?
Yes.
So watch. What if I did this? I'm going to get rid of the 2.25. Divide this side by 2.25. Divide this side by 2.25. That leaves me with, check this out, P plus W equals, what is 900 by 2.25? That's 400. So this one, I'm going to divide by 3, divide by 3. Therefore, I'm left with P minus W. What is 900 divided by 3? 300. Look at this system that we got left with right here. Can we solve this system?
Right.
Yeah, elimination. What are we going to eliminate? The W. So we're left with P plus P, that's 2P. 4 plus 3, that's 700. Divide by 2. So what is the plane speed? 350 what? Miles per hour. Now that we're done with the plane speed, which equation do you want to use to find the wind speed? The red one or the blue one? Red, P plus W equals 400. But instead of P, I'm going to substitute 350 plus W equals 400 minus 350 minus 350. The wind speed is 50 miles per hour. So our statement, the plane's speed is 350 miles per hour, and the wind's speed is 50 miles per hour, 10Q. Fairly simple? Yes, Mr. Q. Our home plate for tonight is found on page 309. There's tutoring today. If I don't see you guys tomorrow. Bye.